Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first, a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time, but I want to provide an additional mechanism to ensure any questions we miss get answered. If you'll visit aka.ms/Azure ATP community, you'll be able to ask a question on our Azure ATP forum. If you're listening to this after the fact as a recording, that's also a great place to ask your questions. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/AATP recordings. While you're there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. Also, you can give us any feedback about this webinar on aka.ms/AATP webinar feedback. So we hope you'll tell us how we can improve there. We've got a fascinating topic for you today. We'll be talking about Azure Advanced Threat Protection. Specifically, we'll be focusing on detections. This is a follow-up. It's part 2 of our detections discussion. I'd like to introduce you to our presenters, Tolly Ash and Atai Grady. They're members of the Azure ATP engineering team, so they have deep expertise in this topic. Without further ado, I will turn it over to them. Tolly?
Thank you, Ryan. So today we are going to discuss shortly about Active Directory and how it stores user object data. Then we'll talk about domain controllers replication process, how domain controllers communicate, and then we'll demonstrate some relevant attack techniques and how Azure ATP detects it. Here you can see all the different detections Azure ATP covers. In blue, you can see all the detections we talked about in the first webinar. And in bold, you can see all the detections we will cover today, from reconnaissance until the domain dominance. Grady, the mic is yours.
Thank you, Tali. So to understand today's detection, we need to have an overview of some topics around Active Directory. First, what's Active Directory? Active Directory provides secure, structured, hierarchical data storage for objects in a network, such as users, computers, printers, and services. Active Directory, also known as AD Domain Services, provides support for locating and working with these objects. Independent software vendors and end-user developers can use Active Directory Domain Services programming to directly enable their products and applications.
Ataya, you may be muted there. We lost sound.
Sorry.
No problem.
Can you hear me?
Yep, we can hear you now.
Is it just from this slide? Okay.
Yes, just from this slide.
Active Directory represent the physical entities that make up a network. Each object type, also called as a class, in the Active Directory has a schema, which contains a specific set of mandatory and optional attributes. When you create an object in Active Directory, you provide the values for the attributes of the object in its particular class. For example, when you create a user object, you provide alphanumeric values for the user's first and last name, the logon identifier, and perhaps other values such as telephone number and address. You cannot create the user object successfully without providing acceptable values for the username and logon identifier, because these attributes are mandatory. In this case, users must have the logon ID, which is used to identify them in the authentication process. Some interesting attributes that attackers usually look for in different objects are group membership, which helps them identifying sensitive users, which are members of interesting groups such as domain admins. Other attributes such as password, empty password allowed, and password never expires assist attackers in their latter movement phase by indicating potential brute forceable accounts. And service principal name and trusted for delegation are interesting attributes, which we'll cover soon in specific attack scenarios. Let's talk about the directory structure. By default, the Active Directory Domain Services for an enterprise contains the following partitions. The schema partition, which contains the class schema and attribute schema objects that define the types of objects that can exist in the forest, what we just talked about. Every domain controller in the forest has a replica of the same schema partition. The configuration partition contains replication topology and other configuration data that must be replicated throughout the forest. Every domain controller in the forest has a replica of the same configuration partition. And the domain partition, which is our main focus here, the domain partition contains the directory objects, such as users and computers associated with the local domain. In contrast to the last two partitions, configuration and schema, which are the same for the entire forest, the domain partition is unique per domain, meaning that each domain inside the forest will have its own domain partition. So domain partition will be replicated to all domain controllers for that specific domain. Partitions are organized hierarchically. Each node in the tree is a logical container. In the domain partition, as you can see in this screenshot, is the organizational unit, also named the OU. An object within the OU has a canonical name, as you can see here, the names, which identifies it. In addition, object has a distinguished name, which is its unique path in the entire domain. So if we look at this example, the OU, which is a logical container users, belongs to the org and test OU. And inside it, we have the Arlene Banks user object. And this object, which is her canonical name. And this object has an attribute, a named distinguished name, which contains the path to this specific object, the canonical name Arlene Banks, and the OU that she belongs to. User and computer objects are security principals. Groups can contain users and computers and other groups, and each security principal has a unique security identifier, also called as object seed, or shortly just seed. And in domain environments, seeds are built from the domain seed, which you can see here, and a relative identifier of the security principal, which is actually a sequential number. So for example, we have a user that has this domain seed, which means this user belongs to this domain, and the relative ID of 1, 2, 3, 4. Some well-known relative IDs you can see here. You can see the domain seed. Okay, domain seed with the relative ID of 500 is always the built-in administrative account of that domain. The 501 is the guest account. The 512 is the domain admins group. In enforced environments, the root domain seed, as you can see here, and the 519 read is the enterprise admins group. If you remember in the first detection webinar, we've discussed the golden ticket attack. In this attack, domain admins read, this one, is being added to the golden ticket that the attacker creates. Active Directory objects data can be queried through several APIs, such as SAMR, which is the remote API for Security Account Manager, the Windows Management Instrumentation, which is known as WMI, AD Web Services, and of course, the LDAP protocol. Each of these protocols are being used or abused by attackers to gather information about the target domain activity, which is known as reconnaissance, or short, just recon. In this activity, the attackers usually look for the list of users and computers, sensitive users with high privileges, objects with delegation permissions that can grant the attackers the ability to act on behalf of any domain user against specific services. And in addition to that, attackers also look for services which runs by users' permissions, which goes by the name Kerberos, you might be familiar with. So let's have a quick demo which will demonstrate how attackers abuse these techniques. So just a second. Sorry. Okay. So we have user 1, which is a regular user in the target domain, which just got compromised. And the attacker would like to do some recon, to gather some information again of the target domain. So what the first thing that the attacker can do is actually using built-in command of Windows called net. And for example, it will look for the domain admins group to get the list of users which are a potential target for this attack. So I can ask for net group domain admins /domain. This will give me the list of the user members, the membership of the domain admins group. As you can see here, user 2 and some other users are part of this group. I can also query the specific object of the user. For example, I can ask for the user 2 details. This will give the attacker some additional information on the user account, like the name, the full name, some relevant information on the password of this user, and its group membership. In addition to that, the attacker can also get the entire list of the users in this domain just by querying net user /domain. I will get all of the user accounts in this specific domain. I can save it and use that for brute forcing additional accounts. And also, I can get the group membership in this domain by the same technique. Okay, now I have the security groups which might be interesting for the attacker. In addition to that, This specific technique used the SAMA protocol. The attacker can use also LDAP to query for additional information. As I mentioned earlier, one of the things that attacker can use to get additional credentials, that to compromise additional identities in the environment, is the use of Kerberos roasting. In this technique, the attacker will use LDAP query, okay, a simple LDAP query that will get the entire list of accounts, and from that account, from that list, look at the specific users that has service principal name attribute assigned to them, meaning that there is some service that runs with these user credentials. And why that's interesting, because once there is a service that runs on any user account, if you remember from the first webinar, the detection webinar, you can use Kerberos with any user to request ticket for that service. So I will request a ticket for some service that runs on my account, like Itai's account, and then I can use brute force, dictionary brute force, to try to find the credentials of Itai locally. I don't need to brute force the domain for that. So to do that, there is a simple PowerShell script that anyone can get download from the network. It's on GitHub that actually use LDAP to query the user accounts with SPNs. So if I'll run it in this domain, I will see that the KERB-TGT has an SPN, service principal name, assigned to it. In this case, kadmin change password. But let me assure you that on large environments and real organizations, you'll have a list of several accounts that actually has SPN assigned to them, and the attacker can request ticket for them and brute force to get additional information. So now Tali will show you how these detections looks like in Azure ATP. Tali, back to you.
Thank you, Grady. So let's start with with the last attack that Grady demonstrated, which is security principal reconnaissance using the LDAP protocol. As you can see in Azure ATP, you can find a detailed description about what happens, that an actor on this computer sends suspicious LDAP queries to this domain controller, searching for 3 types of enumerations: all accounts, all sites, all subnets, and 2 sensitive groups. And it all happened against 3 domains. In the evidence section, you can find more relevant information about what happened in these suspicious activities and relevant and additional information that can help you as part of investigation. For example, we give you some information about what Azure ATP learned before this suspicious activity occurred on the source device, how many LDAP queries it made in the last 10 days. You can see that the 2 groups that were enumerated are sensitive, and also you can find detailed information about the LDAP queries that were generated, and the all accounts queried is the query that helped the Grady to get the SPNs to get the users which have SPNs to them. In addition, you can also download a detailed Excel of the alert. I did it in advance, so I will just show you, that gives you more detailed information about what happened in the alert. First, you have the summary tab where you can find the title, description, the time of the alert, its severity, status, and so on. You can see the source computer that generated the activity, the domain controller that was queried, and here you can see all the different event activities that were captured as part of this query attempt. You can see here the detailed information and the detailed information about the LDAP queries themselves. In this case, we see LDAP search events. Now I will show you the second alert that was raised, which is user and group membership reconnaissance using the SAMA protocol. We can see here that user 1 on client 3 sent the suspicious SAMR queries to this domain controller, searching for all users, all groups, and user 2 and domain admins, which is exactly what was just demonstrated. First, we saw domain admins, then user 2, and then all users and all groups. You can see that these SAMR queries are new. They were not observed recently performing from client 3. User 2 was not observed logging into client 3 recently, and it made it more suspicious because user 2 was queried. And you can see that both entities that were queried, user 2 and domain admins, are sensitive. You can see here that user 2 is sensitive because it is part of the group domain admins and administrators. In addition, you can click here to learn more about this alert, and it will direct you to our documentation. In this documentation, you can find specific documentation per alert type, which details about what is this alert, what is this attack technique. If there is a learning period, we detail how long is the learning period, and we give you recommended steps to investigate the alert to understand if this alert is true positive, benign true positive, or false positive, then how to understand the scope of the breach, and then suggested remediation and steps for prevention. Brady, I'm handing it back to you.
Great, thank you. Let me share my screen again. Can you see it?
Yes.
Great, thank you. Okay, so let's say the attacker managed to move laterally till getting access to domain admin credentials. So I was talking about Active Directory and how it stores really relevant information on our domain. This Active Directory is actually any domain controller, as I'm just connected to, has an instance of the Active Directory in its file system. So as you can see here, under Windows NTDS file is the instance of the Active Directory, meaning this is the database that stores all of the objects and relevant information of this specific domain. So if I'm an attacker, which is what I'm reflecting right now, if I'll try to copy that to my machine, let's say I compromised client 1, okay, this is my machine, I will try to copy the NTDS file and exfiltrate that to my command and control server. So as you can see, if I'll try to copy it regularly, I will get file in use and it will fail because it's protected by Windows. But there is a tool, there is a built-in command that attacker can use, which is built in the domain in any system, which will create a shadow copy of the entire drive, meaning that the attacker can have a shadow copy of drive C for this example, and copy from that shadow copy the NTDS file to the target machine. So I'll demonstrate that. I'll use the VSS admin tool, which will create a shadow copy for drive C. So now I have a path to my shadow copy. Okay, shadow copy of drive C. I will copy from that shadow copy. So it's a long command, so I copy paste it. And Windows. Okay, Windows NTDS file to my exfiltration folder. And as you can see here, you can see that the NTDS file is being created and being transferred to my compromised machine. So believe me, in a few moments, it will be successfully copied. So now the attacker owning client 1 can exfiltrate this file, this entire directory, to the command and control with the C2 communication, and they will gain full compromise of this domain. You can use any user account in this entity.state file to access later on this domain, and not just domain admins, for example. Tali, do you want to show them the alert of the SMB exfiltration?
Yes, please. Here you can see Azure ATP alerts for the exact data exfiltration over SMB we just saw. You can see that an actor on DC1 suspiciously copied file to client 1, and in the evidence you can see the file name and its size. I would like to show you that Azure ATP alerts are currently available in the new Identity Threat Investigation experience we released just a few weeks ago. So you can now see Azure ATP alert data also in this console, and you can see the exact same information we just show here. You can see that the source machine was DC1, the destination device is client 1. You can see the same description and evidence available over here. Back to you, Grady.
Great, thank you. So I'll share my presentation again. Okay. So for our next detections or attack scenarios, we need to understand a new process, new mechanism, the replication mechanism of how DCs are maintained in sync. So as I mentioned earlier, the directory consists of objects and attributes. Domain controllers, like the server that I just showed you, are servers which maintain instance of active directory. Most environments have multiple domain controllers in each domain for scalability, performance, and liability purposes. And in order to have all instances of the Active Directory in sync, Active Directory has a replication mechanism. The replication occurs at the attribute level of objects, okay? And it is loosely consistent, meaning that the data on all domain controllers does not have to be exactly the same at any given time. Domain controllers, or as we call them, DCs, gradually catch up to the changes made on other DCs. And by supporting multi-master replication, AD overcomes issues such as single point of failure and geographic distance from master to clients. And the replication is pool-based. DC requests to replicate an object from another DC and keeps track of the state of each object. There are 4 types of updates which are relevant for replication. Add, when new object has been created. Modify, when an attribute has been manipulated. Move, when object moved in the directory tree, and when object is being deleted. So how exactly the replication works? Let's say that there is an update on our source DC. For example, a new user created, and the replication interval occurs on the destination DC. The destination DC needs to identify the source to replicate from. In our case, it will identify the source DC as a replication source for him, and request changes from the DC. This request will be done over RPC, meaning that the DC will authenticate using Kerberos or NTLM that we discussed in the first webinar, and ask for changes from this source DC. The source DC will then send the changes, the updates to the destination DC, and then these changes will be applied to the local database of the destination DC. And now, the user that was being created in the first source DC exists in the destination DC, meaning that if the user will try to authenticate against the destination DC, it will successfully authenticate. So I mentioned that the directory domain controllers need to be in sync with each other. So to keep track on different objects, the domain controller uses update sequence number, USN, and this USN is a long counter number that is maintained by each DC. This slide is a bit complex, but We'll have a demo right after it, so bear with me. It will be much more clear at the end. So each update on an object increments the counter, and then this new number will be written back to the updated attribute as the local USN number. So this is the local number that the DC keeps track, used to keep track of this object. In replication from another DC, the replicated USN is stored as current USN, and it's replicated along with the attribute value. Since replication is a multi-master, conflicts of multi-DC updates on the same object might occur. And the replication process uses version, originating time, and originating DC to resolve such conflicts. So that's an example of how USN numbers are used in the process of object modification and replication. So in this screenshot, you can see that the highest committed USN number of this specific DC1 is 515628. Now we'll modify the user user Eric Hall's description attribute and see how the local USN number increased and set on the modified description attribute of Eric Hall's object. So we've updated Eric Hall's description, as you can see here, and this update is being reflected on the user and on the object of user Hall, Eric Hall. So the description attribute has now the local USN, which is higher than the USN that we've just seen. It's 515633. The new updated committed USN number reflects just the changes that we just did on Eric Hall's attribute object. So here, this is DC1. So let's say DC2 is now doing its replication sync from DC1. So DC2 just did the replication and will show the attribute, the object Eric Hall. And as you can see here, this is DC2, and the description object attribute of Eric Hall has originating USN, meaning from the source of update came from DC1, and the USN number of DC1 for this object, for this specific attribute. This is the local USN for DC2, which is maintained only by DC2. So the update, this is the way DCs keep track between changes from multiple DCs. Hope that was clearer. Okay, so now let's go over two attacks that are abusing the replication mechanism, the replication protocol. DCSync attack is one of the attacks that are part of Mimikatz tool, which you're probably familiar with, and some other attack frameworks that added it to their arsenal. Once attacker gain domain admin privileges, they can perform this attack. So how exactly this attack works? First, the attacker needs to discover the domain controller from which he wants to get information from. So this is our source DC, for example. Then the attacker will request user replication and user that he would like to have some credentials of. And the DC will send back the password hashes and whatever data that the user wanted. The classic use case for DCSync is to replicate the KERP2GT account in order to execute the golden ticket attack, as we talked about in the first webinar. So once the attacker has domain admin privileges, he can request the KERP2GT account just by using the replication mechanism by using DCSync. Permission, as I mentioned, in order to run this attack successfully, is having either the high privileges permissions, such as replication directory changes and all and in filter sets. And of course, if you are general administrator or domain admin or enterprise admin, you will have these permissions. And again, using this technique, I can replicate any account that I want from the Active Directory. The second attack that I wanted to talk about, which also uses this replication mechanism, is the DC shadow. This second attack that abuses the replication, in contrast with the DCSync, which extracts information from the target DC, this attack simulates the behavior of a DC to inject and manipulate data on the target domain. How exactly this works? First, the attacker registers a compromised machine as a new fake DC, meaning, okay, now the attacker owns some machine, and it will promote it as a fake domain controller. Then use the replication mechanism to push malicious data to the target domain controller. And lastly, he will unregister this fake DC to remove tracks of the attack. So let's see a quick demo on these two activities. Okay. So let's start with the DC sync. I'll use Mimikatz. As I mentioned, I need to be domain admin. So this attack will be performed by using user 2. Let's see that I'm running user 2. I've compromised user 2, and now I can run Mimikatz DC sync to replicate the KERP-TGT account here. As you can see here, I got the entire object of KERP-TGT. Let's see here. I have the KERP-TGT account, and I can get the NTLM hash of the KERP-TGT, and with that I can create the golden ticket. And for DC sync, it's a bit more complex, because for DC sync I will use this specific machine and will promote it to a domain controller, also by using Mimikatz. But then I will run two Mimikatz, one to make my machine a DC, and the other to control it to push my changes. So first, I need to to promote my machine using the system account, and I will run Mimikatz DC shadow. Let me change the resolution. Okay, so I have Mimikatz DC shadow and the changes that I would like to push. In this case, I will update or manipulate the user1 object. As you can see here, the distinguished name of user1, and set the attribute seed history to reflect high permissions, the 500, this meaning that administrative account of a second domain in my environment. So I run that, and now my Mimikatz here is waiting for a push command from the second Mimikatz, the controller. So I run the second Mimikatz, and here I'll tell DC shadow, push the changes, and update the destination. As you can see, the object has been pushed, and my attack was the DC was unregistered. So now there is no track that any DC got from any machine got promoted, and the changes were set to the Active Directory. Tali, back to you, showing the alerts. Can you hear me?
Yes, thanks.
Okay, sorry.
So let's start with the first attack we just saw, which is a suspected DC sync attack, replication of directory services. You can see here that user 2 on client 1 sent a suspicious replication request to DC1. You can see here the source user, the source device, and the destination device. You can see that the source device is not recognized as a domain controller. As was just explained by Grady, replication process is a valid process between domain controllers. Azure ATP is trying to identify suspicious replication queries which are generated from devices which are not domain controllers. Therefore, we give this first evidence. The second evidence also highlights the certainty of this client resolution. Azure ATP is relying on network activities, and in the network activities, we are getting IP addresses. And from these IP addresses, we need to resolve computer names to computer objects in the Active Directory. Therefore, If the resolution is high, it makes the confidence of the alert higher. So this was the DC sync attack alert. Next, I will show you the DC shadow alerts. Here you can filter by the policy name of DC shadow, and you can see we have two different alerts. Why is that? Because it was just demonstrated, DC shadow attack consists of two different steps. The first step is to promote yourself as a domain controller, and the second step is to send replication request to push your desired data. So let's start with the first alert. Here you can see that client 1, which is not a valid domain controller in the domain, registered as a domain controller. You can see that client 1 was registered and unregistered in a very short amount of time, and that client 1 is not a Windows Server machine. In the second alert of the domain controller replication request, you can see the similar data, that client 1 sent changes to the directory objects, although it is not a domain controller and even is not a Windows Server device. So what we talked about today. First, we learned a little bit about the Active Directory and the user objects stored in it. We demonstrated relevant attack techniques in the reconnaissance phase, and we raised two different alerts, user and group membership reconnaissance and security principal reconnaissance. Then we saw how you can exfiltrate data over SMB. We demonstrated exfiltration of the anti-ds.dit file and raised data exfiltration over SMB alert. In the second part, we learned about how domain controllers communicate between them, and we demonstrated two attack techniques, the DC sync and DC shadow. Here you can find additional resources that you can use as part of your investigation, as our security alerts guide. You can learn more about the relevant protocols that you can use to query the Active Directory. You have a link to our Azure ATP attack simulation playbook, which you can use to simulate some of the alerts and raise alerts inside Azure ATP. And you're welcome to join our Azure ATP community where you can raise questions and feedback, and it comes directly to us. Ryan, back to you.
Great. Thank you, Tali, and thank you, Itai. All right, so we've got a question here. Read this out to make sure I get it correctly here. Would someone be missing data and alerts in Azure ATP if their domain controller is not running DNS or DHCP?
Thank you, Ryan. So as I mentioned in the DC sync alert, Azure ATP is trying to resolve IP addresses to computer names and then to look for these computer names to device objects in the Active Directory. For that process, which is called network name resolution process, we are using different methods. And they are detailed in our documentation. One of them is reverse DNS. We also use NetBIOS and RPC over NTLM. So as long as at least one of these methods is enabled in the organization, Azure ATP is supposed to work fine. However, it is recommended that most of the sensors will have access to use one of these methods that Azure ATP can reach can successfully resolve IPs in the network. I will paste the relevant documentation in the Q&A window.
Perfect, thank you. Another question here. Monitoring is great as we've seen, but what about auto remediation? Has it been checked in the previous webinars? How do I tackle and kill these threats once they're spotted?
Okay, so some of these attacks, specifically the recon attacks, we have documentation on how you can harden your environment in order to prevent the attackers from doing it. You can look for Samaritan. I can share some links on top of that, but not everything can be blocked. Like LDAP is something that you cannot really remove from your environment. But some of them, like Sama, you can block the ability to query it remotely.
Okay, great. We've had a couple questions around licensing. Can you guys speak to what licenses are necessary to use Azure ATP?
Yes, Azure ATP is available with E5 license, whether it's EMS E5 or M365 E5.
Okay, great.
You can also purchase a standalone license of Azure ATP. Yes.
We've got one question here kind of related to the unified portal. Will the Azure ATP functionality be moved into the MCAS feature portal in the future?
Yes, this is a process we started a few months back, and a lot of Azure ATP features are already ported to the new identity threat investigation experience, and we are keep investing in that.
And I should mention we did a separate webinar on the unified portal experience, so you can find the recording of that at aka.ms/AATP recordings. So another question here. You guys mentioned Mimikatz in your demos. For people who aren't familiar with Mimikatz, can you talk a little bit about it as an attack tool and what it does?
Sure, no problem. Mimikatz is an attack tool that was written by some enthusiastic security researcher, Benjamin Delpy, which actually uses some legitimate protocols and legitimate API calls to do most of his activities, like I showed earlier, the DCSync and the DC Shadow, but it also harvests credentials from the local machine, meaning it injects itself to the ELSA process, which is responsible for any authentication in the local machine of that specific local machine. And from infecting its memory, it will find and locate the structures in memory that contains the password hashes, such as the NTLM hash and the Kerberos tickets, and etc. So he can extract this information, keep it locally or exfiltrate that or whatever, and also create new tickets, like creating new files that can be pushed back using legitimate API calls to inject a Kerberos ticket, for example. So you can both harvest credentials from local machines, and once you get you compromised privileged user, you can do that remotely on some other domain controllers or any other sensitive machine.
Great, thank you. Can you speak a little bit about multi-domain attacks or how these issues come up across forests?
Sure. So most of the recon attacks that we discussed here can be done against in multi-domain environments. I mean, once you have trust between domains, I can run recon from one domain to another and get this information from multiple domains for the entire forest. And all of these will be covered by Azure ATP. The DCSync, or the ones that you need to have high privileges, you would need to do some additional malicious activities in order to gain higher privileges on the other domains that you didn't compromise. So these will require some additional efforts from the attacker. But yeah, most of them can be easily done against all forest.
Okay, excellent, thank you. You kind of referenced this in your presentation, but I just want to call it out to make it explicitly clear. Does this solution work across both cloud and on-premise?
This solution, you mean? What do you mean by this solution?
Azure ATP. I mean, can people use this both for their on-premise detect on-premise attacks and for their cloud attacks?
Tali, do you want to respond to that?
In the unified identity investigation experience, we offer protection for both on-premise and cloud environment by Azure ATP and Microsoft Cloud App Security products.
Okay, great, thank you. Let's see, we got. We've got a, okay, that's another question around licensing. While we're waiting for additional questions here, I'm going to remind people of some links we have here. If we somehow missed your question, or if you're listening to this as a recording after the fact, you can ask any additional questions at aka.ms/AzureATP-community. If you're looking for recordings, whether it's of this one or whether it's of any of the previous Azure ATP webinars we've done, you can find those at aka.ms/AATP recordings. And you can join our community at any time by going to aka.ms/security-community. And we would love to hear your feedback about this webinar and what we can do to improve it, or what you liked about it, at aka.ms/AATP webinar feedback. Check, we've got an additional question here. Will the Azure ATP portal get deprecated in the future, and is the plan to use MCAS instead?
We are currently in the effort of unifying different security products portals into one investigation experience. Currently, there are no plans with ETA to deprecate the current console, but it is warmly recommended to move to the new experience.
Okay, great. We've got some feedback here. Licensing is a bit confusing as this feature is domain level sync, not user level, and the license required is user level E5 license. Can you explain how that works?
So in terms of licensing, you should have an organization license, which is E5 license for any user in the organization.
Okay. What's the minimum version of domain controller? Does it also support resource forests as well as user forests?
Grader, do you want to take this one?
Sorry, can you repeat that?
Let's see.
Minimum version of domain controller?
What's the minimum version of domain controller, and does it support resource forests as well as user forests?
I think it's 208 version, if I remember, right? Azure ATP Tally, just correct me if I'm wrong. But we do cover, if you look at the traffic like that, we do cover any traffic that really goes to other domain controllers. Regarding resource forest, do you mean like domains that doesn't have users and only for resource purposes, right? It doesn't matter, because these resources are also accounts, and we protect any account, no matter what, if it's a user or not. Hope that answers your question.
Okay, great. We've got someone asking for an ETA for role-based access control support for a multi-forest. Is that something we're working on?
There is no ETA for that yet.
Okay. Another question here. What about E3 with an Azure ATP Plan 1 or Plan 2? Does that support, do people get access to Azure ATP from a licensing standpoint there?
I'm not familiar what is Azure ATP Plan 1 or 2, but E3 is not enough for Azure ATP.
So in E3, we do include the Advanced Threat Analytics solution, which is not cloud-based. It is an on-prem only solution. We do not have any Azure ATP offering today as a part of E3. And for that, people can step up into the E5 and be using the Azure ATP solution.
Great, thanks, Eyal. Another question is, does Azure ATP replace ATA?
So as just said, Azure ATP is the next generation of ATA. ATA was released a few years ago as an on-premise solution only. So it covers on-prem activities, but all of the processing is not happening in the cloud. Azure ATP solution was announced almost a year and a half ago, and this is the next generation of ATA.
Okay, great. This one's more
is EMS, yes.
This one's more of a piece of feedback. Someone was mentioning how they missed the first webinar, would like more information on how to get Azure ATP up and running. Our previous webinars were on detections and on the unified portal, but we'll take that feedback, and it might be worth looking at doing a more introductory and configuration-based webinar. So thank you for that. Okay, with that, I don't see any additional questions that we haven't addressed, so we'll wrap up here. I want to thank all the people who were answering questions in the background here for those who asked them over IM. And I want to thank, of course, Tali and Tai, who gave a wonderful presentation today and walked us through this complex and fascinating topic of all these sophisticated attacks and how Azure ATP detects them. And of course, I want to thank all of you who joined us for being members of our community and attending our webinars. Please check out the recordings if you didn't get a chance to catch the full thing, or if you want to check out any of the past ones, and we will see you on our community. Thank you, everyone.